Okay, here's our first homework video, chapter 12 solutions. The way I like these homework packets is I want you to go through and do some reading, use the internet, use the readings I provided on Canvas, and work as a whole. Now, I'm giving you more independence, like I said in class. So with that independence comes responsibility. I'm providing answers. Use this as a tool to help you learn, not incorrectly where I would assume you would just turn in your packet with the answers on there. So don't do that. You don't want to be that person. So let's get started. We're starting off. We need to do 12.1 to 12.3, 12.4a, 12.5, and 12.6. I'm going to try and do the first few of each one and go from there. So let's see. My purple marker. Highlight. I want you to go through, take notes, and highlight these. And figure out like what you know, what you don't know. These right here are always optional. Excellent if you do, you don't have to. Key terms, do these. Now, the way these work, you could just go through and write down the letters, but if you come across something you don't know, look it up. Find the right answer. Solutions, definitely want to do this. So, as we come across here, one of the main things we're going to look at, of course, is 12.1a. So now we were looking at what dissolves what. So in that scenario, we're going to use our rule like dissolves like. So if it's polar, it dissolves a polar solvent. If it's nonpolar, it dissolves a nonpolar solvent. So in this first one, bromine is nonpolar. And then it says in our reading that hexane is the solvent that's nonpolar. So obviously like dissolves like. This would be hexane. Now I check my answer. Boom, hexane. Excellent. Okay, moving on. Indicate the solute and solvent, each of the following. Well, if you remember right, solvent is more than solute. All right, so with that being said, with 10 grams of Cl and 100 grams of water, the solute would be 10 grams and solute would be KCl, solvent H2O. Check my answer. Excellent. Down here, you have different percentages. You have different pressures. That's fine. Different milliliters. Make sure it's the same amount. Electrolytes and non-electrolytes. Electrolytes conduct electricity because they completely dissociate. So the question is, what is a strong electrolyte? It turns into ions. So when we look at ions, we think of ionic bonds. So when we think of ionic bonds, we think of metals and nonmetals. Right? A column on the left balancing or chart with the charges on the column on the right. So use your periodic table. Write an equation for the formation of an aqueous solution with the following strong electrolytes. So cool. I'm going to highlight a few things. This is an aqueous solution, which means I'm going to be using water. Another word for that is hydration. Strong electrolyte, which means they're completely going to dissociate to two different things. So the first one, Li. It's supposed to be an H. Li is a +1. Chlorine's -1. Cool. That's one way of writing it. There's another way of writing it. You could just put aqueous or the H2O above the arrow. Scroll down here. Perfect. All right, so that checks out. Now you could, of course, put these aqueous signs instead of water, to each their own. All right, indicate whether an aqueous solution contains ions-only molecules or mostly molecules with some ions. So you have a few things here. The first thing we're going to talk about is it contain ions only. So another word for that would be strong electrolyte. Mostly molecules and some ions. Well, that would be a weak electrolyte. Then write an equation for the formation of, oh, I forgot this one. molecules only. Another word for that we've come across is insoluble. So it doesn't change the chemical composition when it's dissolved in water. All right, so glucose, a non-electrolyte. All right, another word for molecules only, insoluble. You guessed it, non-electrolyte. Cool. So glucose, non-electrolyte, which means it would make molecules only. So with that being said, well, just molecules. Molecules of what? Molecules of C6H12O6. Awesome. Moving on, 12.3, solubility. This is important. This is really, really important. You need to memorize these two sentences. That will help you tremendously. Lithium, sodium, potassium, nitrate, ammonia, all soluble in water. Halides, sulfates. Halides, definitely like chlorine, bromine, fluorine. Sulfates, that's an SO4 3-. So all those dissolve in water. Cool. All right, sugar. When you add sugar to coffee, well, if it's hot coffee, it'll get dissolved up. If it's cold coffee, it'll sink to the bottom. Now, we don't change the chemical composition of sugar. It stays the same. So that is what we would consider unsoluble. Versus KCl crystal, we know KCl is ionic bond. That would separate due to the dipole moments. That would be soluble. Or saturated, sorry. All right, here we go. Solubility, NaNO3. So this is cool. Let's get started. So let's just blatantly read what we have here. This means at 40 degrees Celsius, 100 grams of NaNO3 is dissolved into 100 grams of water. Okay, so read my question. How many grams of NaNO3 will dissolve in 100 grams of water at 40 degrees Celsius? Well, always start with what we're given. And we are given 100 grams of water at 40 degrees. So, we start with that. Sweet. So what the quick review. This 100 grams associates with this 100 grams. This, and it gets really confusing with all the different colors. Here, NO3 associates with this right here. All right, so that's my ratio, 100 to 100. And then, of course, my units would cancel. So let me just get a quick marker here. 100 grams of water cancels grams of water, and I'm left with grams of sodium nitrate. How many grams of sodium? Oh, moving on. Soluble or insoluble? This is where those sentences I told you memorize come in handy. So go back up, look at that, memorize them, and come back. Pause if you have to. Sodium chloride, definitely soluble. AgNO3, NO3 definitely soluble. Cool. PbCl2, definitely not. Lead is not soluble in water. Awesome. Move on. If you have questions with these ones, go up to the top, scroll up, read this, learn it. If that gives you problems, use the reading that I assigned in the book, or not in the book, on Canvas, on that PDF.